In this video, you'll see how to calculate logarithms with the TI-84. So logarithms are this mathematical operation where log base b of a equals p really means that a is equal to b to the p power. Because of this, generally speaking, we always force our base of our logarithm to be greater than 0, so base to be positive, and not equal to 1, because 1 to any power is always 1. So log base b of a equals p means a equals b to the p power. Let's go ahead and calculate some logarithms. Some logarithms that we can see on our calculator are log base 10 and log base e. The calculator has a log base 10 button, and the way the button looks, it just says log. The calculator also has a natural log button. Natural log is the log base e, that is the irrational number e associated with continual growth. And log base e, or the natural log on our calculator, looks like ln of x. So we can actually just type these things into our calculator directly on the home screen if we want. I'm going to go ahead and do that. Here we have log base 10 of 10,000. Notice that if you don't see a base, you automatically assume it's base 10. And then we'll do log base 10 of 462. We'll do natural log of e to the 5th power, and we'll do natural log of 945. Here we are on the calculator. So we're going to do those log equations. The first one is log of 10,000. On the calculator, the log base 10 button is right next to the 7. So I just push that and then enter 10,000. You'll notice that this gives me a 4, which should make sense because what we're saying is that 10 to the 4th power is equal to 10,000. That's the exponential equivalent to that statement. I can do the same thing with log of the other numbers. So for instance, we had log base 10 of 462. Again, that's just that log button. We get 2.664, so on and so forth. And that means that if I take 10 and raise it to that power, I would get 462. Obviously, if you used a rounded version, if you used 2.66, you wouldn't get exactly 462, but you may get fairly close. If I'm trying to do a natural log of something, that's right next to the 4 button. So I just hit natural log. The e to the power is also second and then the natural log. So in my case, it says take natural log of e to the 5th power. Obviously, that's 5. We're saying e to the 5th power. E to what power is equal to e to the 5th? Well, that's e. That's 5. So e to the 5th is equal to e to the 5th. And then we had natural log of 945. And what we're saying is that e to that power, that 6.85, so on and so forth, is equal to 945. Now, the natural question arises, what if we don't have base 10 or base e? There's a couple of approaches I can do. to finding a log of a different base other than 10 or e. One of them is to use the change of base rule for logarithms. This says if I have log base b of x, that's going to be the same as log base a of x divided by log base a of b for any a value. In particular, if this a is 10, then we get our log base 10. If we use a as the number e, then we get the natural log. So we can take log base 10 of x divided by log base 10 of b, and that'll give me log base b of x. Let's go do a couple of calculations. Here we have log base 2 of 16 and log base 5 of 341. Let's take our calculator and use the change of base rule to calculate these two. So if I were to use the change of base rule to calculate log base 2 of 16, I can use either the log base 10 or the natural log. I'll use log base 10 first. Log base 10 of 16 divided by log base 10 of 2 becomes 4. And that should make sense because we're asking what exponent do I raise 2 to get a 16? And that's 2 to the 4th is equal to 16. The same thing could have been done using the natural log. We could use natural log of 16 divided by natural log of 2, and sure enough, we get a 4. Now for the other one, it was log base 5 of 341. I'd take log base 10 of 341 divided by log base 10 of 5, and I get that number. And I'm saying that 5 raised to that power should give me 341. So that is the answer. That is the log base 5 of 341. It's about 3.62355, etc., etc. You could have done it with natural log as well. It's kind of a preference. Make sure that whatever I use on top, whichever logarithm I use on top, I use that same logarithm on bottom. So if I'm using natural log on top, I use natural log on bottom. If I use log base 10 on top, I use log base 10 on bottom. So that's how to do it using this change of base rule for logarithms. Now, the other thing most TI-84s have is they have a log base B feature. It's in the math section and then under letter A. So let's go back and do these same two problems using the log base 2 and log base 5 directly. So like I said, to get a log base 2 without having to use a change of base rule, I hit math and then I scroll all the way down to letter A. That's log base. In my calculator, it gives me this look. So I put a 2 as a subscript and then a 16 in as the argument. And sure enough, I got 4, just like I got using the change of base rule. Again, math, scroll down to A, log base 5 of 341 gives me that exact same number I got with the change of base rule. So that's another way you can do that. By the way, the reason my calculator looked the way it did was because in the mode section, I was using the math print. If you do have the classic mode operating system turned on your calculator, then when you go to math A, what you would have to do is you'd have to hit the argument first and then comma 2. So that's log base 2 of 16, log of 16 with base 2. And the same thing would go if we were talking about log base 5 of 341. We'd start by typing in the 341 and then hit a comma and then a 5. And we get that 3.62 number again. So that's how to do calculations with the TI-84 with any base that we want, including the base 10 and the base E or natural log logarithms.